Today we are going to talk about poured in place concrete, and we're going to start with poured in place concrete foundations. Poured in place concrete construction, typically if we're doing poured in place, the forms are going to be in place at the job site. Then they are going to come in and they're going to place the steel reinforcing bars into the forms, pouring concrete into the forms around the reinforcing bars. That is typically the process for poured in place concrete. You've seen the trucks that have the big spinning containers on the back of them. That is so that the concrete stays in the proper consistency as it goes from the plant to the job site. Once they get to the job site, like if you look at the middle picture, they have usually some kind of an extension that comes off of that truck that they can place the concrete. And the guy with the hose that's going into the concrete is actually getting the air out of it, because as it's dropping, it's making air pockets. So they have to go through and get the air out of that concrete so that it stays consistent. The picture on the right is showing the reinforcing bars that are put into the concrete before it is poured. The picture on the left is the actual forms themselves. Again, most times, depending on what kind of construction, the forms may be wood or they may be some type of plastic material. They put some type of material on the inside of those so that when they remove them, they're easily removable from the concrete. When we are doing poured in place concrete foundations, we have two types of drawings. We have engineering drawings and we have placing drawings. Engineering drawings are done by the engineer. That makes sense. The placing drawings are done by the person supplying the concrete. You might also refer to these as shop drawings. Engineering drawings typically take place before a project is bid. Placing drawings take place after a project is bid. Engineering and placing drawings. They both show the general layout of the structure, the size and spacing of the structural components such as foundations, walls, beams, and columns, and then there will be various notes containing information helpful in understanding the drawings. They are typically drawn to scale according to the overall size of the structure, the size of the sheet when the structure is being placed, complexity of the project, and individual company preferences. Typically, again, any place you go to work, they're going to have their own standards of how they want things set up. Engineering drawings and placing drawings typically come in standard scales. I don't always agree with what the book says on this. I try to typically keep my plan views and my elevation views at the same scale. Sometimes we may need to do some enlarged elevation views, but my overall elevation views I typically keep at the same scale. Section views, again, my overall section view I try to keep at the same scale as my plans and my elevations, but then I can do blow-ups of individual areas for the sections. Here is a typical sheet layout that is set up by the American Concrete Institute, and you'll notice on the left we have a plan view, on the bottom we have sections and details, on the right we have schedules and notes, and again we have a title block. Every sheet should have a title block. Poured in place concrete drawings for placing drawings. You'll see there is some additional information that needs to be on the placing drawings. You have a plan view, you have sections, elevations, and details. You have bending details and reinforcing bar schedules. That is important. We then have schedules and notes on the right side, and again a title block sheet. Poured in place concrete drawings, they typically, for your shop drawings or your placing drawings, they need some kind of a marked numbering system. And this is needed to manage the drawings and construction of the separate but interrelated parts. It relates to the component number to the overall job. Example 3B4 refers to beam number 4 on the 3rd floor. And again, this can vary from company to company, but usually a number is used to represent the floor, a letter is used to represent the component, and then a number to represent the specific component. So you see we have floor 1, 2, we have beam, column, footing and foundation, and girder, and then we have a number that goes along with those. Poured in place concrete drawing common drafting symbols. These are industry standards, and as a drafter you should know the industry standards. Here are some common abbreviations. I'm not going to go through these. Again, every company is probably going to have some standard ones, but there are also industry standards that are used. So again, don't be making up your own abbreviations. Use what is standard through industry. This is a beam schedule. We use a lot of schedules in structural drafting. and engineering because it typically ends up being some type of a fabrication process. So you'll see we have a number that says 3B1, and the beam width is 12 inches and the depth is 20 inches. The longitudinal reinforcing is 4 number 6 bars. If it has a number 6, that means it is 6/8, which means that it is 3/4 inch in diameter, and it is straight. Then we have some stirrups and ties. Stirrups tie your reinforcing together. Stirrups go around the perimeter of an object, and ties tie those stirrups together. So in this one we have 16 stirrups that are number 3, which would be 3/8 inch in diameter, and then the ties are the bar spacing, which are 8 at 12 inches. And when we get ready to do our column design in concrete, you'll get to see a better example of this. This is a column schedule for the roof. Again, I have never seen the diagram on the left side of this where they put the dimensions of the floor to floor in there. Typically it would just say the roof dimension, the floor dimension, the basement dimension. But again, I have not been in a structural concrete office before, so it may be done that way. Again, we have the column schedules with the columns, and then we have what size they are, what kind of bars are in them, the column ties, the column size again, the vertical bars, and the column ties for each floor. So how do we set up our poured-in-place drawings? The first drawing in a set of poured-in-place concrete plans is the foundation plan. We always work from the bottom up typically. A complete foundation plan requires both engineering and placing drawings. So once the project is under construction, you work from both the engineering and the placing drawings. Engineering drawings again are used in the design and planning process and are prepared first, and they're typically done by the engineer. Preparing engineering drawings for foundations, you can read through this. I'm not going to read through it for you. It's also in your book. Here is an example of a sample engineering drawing. Again, we have a plan. There are some very bad things about this drawing. There is no title on the plan itself. There is no north arrow on the drawing. So again, the drawings out of your book are not the best examples, but it does have a couple of sections through it. It has some notes on the right. It does have a title sheet, and it does have dimensions on it. So you can see the sample engineering drawing is fairly simplistic. It still has calculated items on it that were done by the engineer. The placing drawings, again, I'm not going to read through this for you. You can read through it yourself. And here is the information about the rebar that goes into it. Sometimes rebar, besides being just straight, needs to be U-shaped or a C-shape as shown here. Whoever is bending the bars needs to know what part of that straight bar needs to be bent. So if you look at 6C1, it says the bar size is 6, which is 6/8 again. So that is 3/4 inch diameter, and it's type C. If you look at the drawing at the bottom, it shows you kind of a U-shaped configuration. The bar starts out at a total length of 5 foot 2 inches. The A dimensions are 24 and the B dimension is 14. So if we add that up, that comes out to 5 feet 2 inches. And then you have the other example for the type F. Here is a placing drawing. You can see it is a lot more detailed. This is how the product is fabricated. We have the bar details and dimensions. We have a lot more information on our two sections, and we have a lot more information on our plan, because the person that's supplying the poured-in-place concrete has to be able to put together a bill of materials and order what is needed for the job site. Once these placing drawings are done, they are sent to everybody to review, and then they are again used on the job site to install the materials. Poured-in-place concrete walls and columns. In building the structure of a building, we typically have walls and columns. We talked about these in the pre-engineered manufactured buildings. Every type of construction we're going to talk about typically has columns. So in this case, we are talking about poured-in-place walls and columns. We don't see this a lot today because we do have the precast and we have steel, and it's usually a lot easier to do it in a controlled environment. than to try to do it out in the field. There are 4 categories of walls. We have security walls, shear walls, tilt-up walls, and retaining walls. And we have 2 types of columns. We have tied and we have spiral. Security walls, they are exactly what they say they are for. The primary function is for security. They can also provide security from fire, break-ins, and noise. Where you'll see some security walls might be in banks, firewalls in apartments, and other commercial applications. Shear walls. When we have strong winds such as tornadoes, hurricanes, etc., we want our concrete to be a little bit flexible, but we don't want it to flex to the point that it cracks or it breaks. So that is what a shear wall does. Structural system composed of braced panels to counter the effects of lateral loads. Wind and seismic loads are most common loads that shear walls are designed to carry. And you can kind of see the demonstration here in the picture. Where we typically see shear walls are in elevator shafts and stairwells. That's really important. Poured in place concrete shear walls provide support for the floors of a building as well as the lateral support. Tilt-up walls. These are exterior concrete walls that are typically tilt-up panels. They can be either precast or poured in place. If they pour them in place, they do their forms, they set them up just like they do before. The only thing they're going to do is they're going to add the clips into the walls, or if they're done as a precast, they will have the clips into the walls so that they can connect to them to lift them up. Poured in place tilt-up walls breaks the rules of poured in place concrete because it's not really poured in place. It's poured in place and then it's moved. Retaining walls. A lot of times we're going to need to hold back earth or hold back water or hold back some kind of environmental concern. We have 2 types of retaining walls. We have gravity walls and we have cantilever walls. Gravity walls basically are wider at the bottom than they are at the top, but they're a solid. They are typically very heavy and they are restricted to 6 feet in height. If they are taller than that, they can tip over. So again, 6 feet in height. Cantilever have a leg that come off of them and it can be formed like this one is. It can have a straight side to it, but if you notice the arrows, this is where the forces are coming from and how the wall is reacting to those forces. It is tapered from the top to the bottom. The bottom rests on a wide footing. The footing is poured in the ground and heavily reinforced, prevents forces of pressure from tipping over, and the vertical portion is heavily reinforced. Columns. Columns are either tied columns or spiral columns. I talked earlier about stirrups. If you look over on the right column, if you look at the plan view, you see you have some vertical rebar coming up. Those are the round dots. And then you have some other rebar that you see going around the perimeter. That is a stirrup. So tied columns are square or rectangular in cross section and reinforced with stirrup ties and longitudinal reinforcing bars. Spiral columns, round and reinforced with spiral wrapped around longitudinal reinforcing bars. Tied columns, typically you have long straight bars tied off with wire ties or smaller bent reinforcing bars. Spiral columns, long straight bars surrounded by spiral wire or reinforcing bars. When we are doing columns that are poured in place on multi-story buildings, we have to sometimes splice them. So as you see in the example, they have rebar sticking out of the top. That way, when we put the next pour, we tie in to the bottom pour. So this can help us achieve heights. Helps us at floor levels. We can splice them there. And most are square, round, or rectangle, but as you see in the diagram on the right, they can be any size and shape. So the placing drawings, again, we're going to have plan views, sections or details, schedules, bending details, notes, and typically are drawn in the same scale as engineering drawings, except for where we need blown up details. Here's an example of a wall placing drawing. You see on the left, again, these drawings are not the best. There is no north arrow. Also, the plan and the elevation are not noted. The top drawing is the plan view. The second drawing is the elevation view. Then you have a section through that, and then you have your bar details, and you have some general notes. This is the column placing drawing that shows the plan itself, shows the columns, the information about the columns. You have a splice detail, and then you have the schedule that shows the bar details and dimensions. Poured in place concrete floor systems. There are several types. There is the one-way solid slab and beam, the one-way ribbed or joist slab, the two-way solid slab and beam, two-way flat plate, and the waffle slab. It can also be ground supported or suspended. So this is an example of the ground supported or the suspended. Most of the time, unless we need a crawl space or a basement, it's going to be ground supported. The building that our classes are held in is a ground supported system. If you want to have a crawl space or a lower level in the basement, something, then you would have more of a suspended system. One-way solid slabs. You have beams that are running in one direction from column to column, and then the slab sits on top of that. The slab is typically 4 to 6 inches and is supported by those beams. You can only use these in short spans of less than 12 feet. It derives its name from the reinforcement used. Main reinforcing runs in one direction from beam to beam. One-way ribbed or joist slab. Disadvantage of previous is due to the weight, especially over 12 feet, so you can use this modified version. Combines a thin layer with concurrently poured joist or ribs similar to a precast concrete double T. Joists or ribs are placed at 24 to 35 inches on center and reinforced with 2 or more reinforcing bars. The two-way solid beam. It is like the first one, but you have beams going in both directions. Used when the slab is square or almost square. The name implies the slab has beams running in both directions, as I just said. Allows for greater floor area with fewer beams and no girders. It is more difficult to construct, but economical because it uses less materials. The two-way flat plate floor system. Most simple system. Floor slab of uniform thickness supported by the columns only. No beams or girders. This is helpful when you need headroom and you're tight on that. Has reinforcement in both directions. They use this a lot for like hotels, apartment buildings, and condominiums. The waffle slab. This is used in applications requiring a thick slab. Thicker the slab, the heavier it is, the more expensive it is, and the less attractive. So cost and weight is reduced by a series of recesses formed into it with a removable filler. Recesses do not substantially reduce the structural capabilities. It's a very, very interesting concept, and you might see this like in parking garages and such. Floor system drawings. Again, requires both engineering and placing drawings. The engineering drawings are going to have the plan view of the floor, sections, slab schedules, and notes. Placing drawings are going to have a plan view of the floor, sections showing precise placement of reinforcement bars, slab schedules, bar detail schedule, and then again it's going to have marks on the drawings to relate so that when they put the bill of materials together and get it on the job site, they know what parts go where. So for example, 1S2 means the slab, number 2 on the first floor. Here's an example of the engineering drawing for a poured-in-place concrete floor. We have the plan, we have the section, we have some notes, and we have a schedule with the mark numbers. And then this is the same drawing as a placing drawing. Again, much more detail on the placing drawings. That is the end of the PowerPoint on poured-in-place concrete. Most of this is in your book. Next, we will move on to making some columns with reinforcing in Revit.